recombination of spectrum of white light. So when we had the white light, okay, pass through a prism, it got split, right? Now, what if we make it go through another prism? What happens? Any guesses? So let's look at this experiment. So we have prism 1. It is creating your spectrum. We have the sunlight and everything. So I'm getting the second prism. Prism 2, and where is the spectrum? Well, I'm searching for the spectrum. We don't see the spectrum. We see a white light. Right, you saw a white light, and that's what happens. So this spectrum recombines. Okay, so they recombine. How does it? It will bend towards the normal. This will also bend towards the normal. And they recombine, and we have the white light again in this way. Okay, so this two prism have the same angle of the prism. So these two have the same value. Understood? So if we place two prism which have the same angle of prism, we will get the white light back. If you think about it, if I name this as P, Q, again this is Q, R, S, and this is S again. So we are looking at a prism which is of parallelogram in shape. So how we saw in our glass slab experiment, wherein we had a shift, right? Lateral shift. The same thing is happening over here. Okay, so white light entered and white light came out. And this is your entire picture. Okay. This is nothing but your recombination of the, okay, not the other spectrum of white light. So it's recombining. So we started with white light. This is your prism 1 and prism 2. They have the same angle of prism. So here it got split and here it recombined. Right? So this is the split and this is the recombination. And end of it, you get a white light. And it's your screen. Okay. So when white light is passed via a prism, it gets split into its component colors. This dispersed light will recombine to white light when another prism of the same angle of prism is held inverted. Condition is angle of prism has to be same for it to work properly.